Today, we look at the consequences of thermodynamic entropy. Entropy is the reason things break. Without entropy, there would be no hysteresis curves limiting the reversibility of so-called reversible processes. No entropy, all particle collisions would be perfectly elastic instead of somewhat elastic or inelastic. There would be no nucleosynthesis and therefore no diversity of elements, no chemical reactions, no change, no growth. Nothing would die, nothing would be born, nothing built, no energy mass conversion, no conversion of one form of energy to another, no reproduction, no renewal, no healing. Without entropy, there would be no de Broglie wavelength. Entropy means that all mechanical efficiencies for all machines, natural or artificial, are below 50%. For example, car engines produce automotive force as a side effect. The vast majority of their energy goes into heat, and some of the energy goes into sound. They torque the drivetrain, converting more energy into heat through friction in the drivetrain. Entropy increases the disorder of systems, thereby destroying information. It fades or decays, garbles, corrupts. Think of shredded, pulped, or burned documents. Think of documents that undergo slow oxidation as a yellow exposed to air. Increased thermodynamic entropy equals increased information ectropy and vice versa. So information entropy is a measure of order given to a system. So ectropy is just the opposite, amount of disorder. Same with the opposite of thermodynamic entropy is thermodynamic ectropy, which is increase in order of a system. Energy to decrease entropy or increase the ectropy, the thermodynamic ectropy, comes from the sun at the expense of increasing the sun's entropy. But it's really huge. It can take it. You can wind a spring decreasing its entropy at the expense of increasing your own entropy through internal chemical reactions. So it's like rolling down a large hill and rolling up smaller hills on the way. That's what that's like. The increase of entropy for larger systems, providing the energy for decreasing entropy in other systems, things that would run down if they weren't charged, right? So you wind a spring, and then the spring unwinds, producing energy or some kind of motive force, meaning that entropy re-increases. And we see decreases of entropy everywhere. But when we do, it's basically a temporary charge or fueling that results in basically a system running down, going from order to disorder. So things have to break, right? We have to chop down trees, we have to saw wood, we have to nail wood, breaking these little metal nails through the wood in order to build things. So it's not possible to create something new without taking something old that had been existent before and changing it and destroying bonds in order to establish new bonds. So there's no exchange of atoms and chemical reactions without entropy. It just doesn't exist. There'd be no matter-energy conversion, either energy to matter or matter to energy, without entropy. Because whenever there's an exothermic reaction, for example, a teeny tiny bit of mass is converted into energy. That's only made possible because of entropy, or entropy is a direct result of energy mass conversion. In fact, these two principles, energy mass or mass energy conversion, that principle is concomitant with the principle of thermodynamic entropy. Okay, so actually existence itself would not be. We could not have any kind of universe with all these assortment of elements and all these different molecules, all these different compounds, all these mixtures. There'd be no mixtures. There'd be no stars. There'd be no planets. There'd be nothing without the principle of thermodynamic entropy, making it all possible, making it so that some collisions are inelastic, making it so particles can actually fuse together, like hydrogen atoms can fuse together to produce helium and release energy, which is what sunlight and starlight comes from.